Welcome to my channel Phi Concepts CHM. This is the seventh part of the band theory of solids, where we will see the distinction between metals, insulators and intrinsic semiconductors. Distinction between metals, insulators and intrinsic semiconductors. Consider an energy band filled with electrons up to a certain value K1 less than pi by A at a temperature of absolute zero. So here in this diagram you can see the first Brillouin zone between minus pi by A and plus pi by A. And this band is filled only till plus minus K1. So you can see this band is filled between minus K1 and plus K1. This is, you are familiar with this diagram. This is E versus K graph. Now consider a one-dimensional lattice of length L. The number of states in an interval dk is given by dn is equal to L by 2 pi into dk. This you had derived in number of wave functions in a band. So you can refer to the derivation of number of wave functions in a band. Now as there are two electrons in each state, we will multiply this equation with 2. So we will get 2 into L by 2 pi into dk. Integrating all the states, we can find N effective, that is the effective number of free electrons, is equal to integration of dn into fk. Substituting dn, we get 2 into L by 2 pi into dk, and inside the integral comes fk into dk. We can substitute the degree of freedom f suffix k as m by h cross square into d square e by dk square with the limits minus k1 to plus k1. The band is filled only till plus minus k1. We will change the limits from 0 to k1 so that we will multiply the integral with 2. So also this d square e by dk square can be written as d by dk of de by dk into dk. M by h cross square is taken outside the integral. So integration of this term will be d by dk. Substituting the limits, we can write down this as N effective is equal to 2 ml upon pi h cross squares into d by dk at k is equal to k1. We will see the different cases. For a completely filled band, k is equal to plus minus n pi by a, where n can be 1, 2, 3, so on. And d by dk is equal to 0. That is, if this band is completely filled till suppose plus minus pi by a, then d by dk, that is the slope of this curve here, it becomes, energy becomes constant here. So its slope d by dk will be 0. Therefore, from the equation that we have derived for N effective, we get N effective is equal to 0. Indicates free electrons in a completely filled band is 0. For incompletely filled band, d by dk reaches a maximum at the point of inflection. So if the band is filled only till plus minus k1, so here you can see that the slope d by dk will be maximum. Therefore, N effective will be maximum. So the band here is filled only up to plus minus K1. Hence, at T is equal to 0 degree Kelvin, N effective will be 0 for two cases. One is for completely filled band as well as for incompletely empty band. This can be taken, completely filled band can be taken as the case for an insulator. So completely filled band indicates materials behave as insulators. All the bands up to the valence band are filled and the topmost band, which is a conduction band, is completely empty. There is a large forbidden energy band gap between both the bands. So it is impossible to excite the free electrons across the gap. Example is diamond, where the band gap energy is 6 eV. Now in semiconductors, the band gap energy E suffix G is low. Example is that of silicon, where the band gap energy is 1.1 eV. And in case of metals, there are large number of free electrons even at low temperature, making them highly conductive. So the valence and the conduction band overlap in case of metals. So large number of free electrons are available even at low temperature, making them highly conductive. All the discussion is shown in this diagram. On the y-axis is the band energy. This is for the insulators. You can see that there is a large band gap between the valence band and the conduction band. This is for the semiconductors, where the band gap is a little less compared to insulators. And in case of metals, the conduction band and the valence band both overlap with each other, so the band gap energy is 0. Thank you for watching this video.